So we're going to be taking a look at our binary trees for the first time. Now, we're going to build a binary tree in this class. The main way to build a binary tree is to start with a root. Each one of these blue circles is going to represent what we call a node. So in a linked list, we used nodes to connect data, and then each node would reference the next node and then the previous node. However, in this case, our nodes are going to reference the left node and then the right node. Each one of these nodes is going to have a few names to it, depending on where on the tree you can find it. So if we look at a set of nodes together, we're going to call that a branch. If we look at nodes that don't have any references to other nodes, there are nodes that are empty in a sense, that maybe have some data, but don't have other nodes underneath them, then we're going to call those leaves. Nodes that have nodes underneath them, in this case, which have references to other nodes, are called parents. And then nodes that are referred to by a previous node, or nodes that are underneath or below other nodes in a tree, are called children. Now, a parent can appear at any point in a tree. It doesn't just have to be the topmost node. That one is called a root. But you can find parents and children at any point. So in this case, we can see that one of the nodes, it's both the parent of another node, in case the green parent to the green child, and it's also the child to another node, which is the orange parent to the orange child. The general idea of a tree is that it branches off at different spots. So we start off with one initial element, and then from that element, you can get to two other elements. And from those two other elements, each one of those is going to let you get to two other elements and so on. And you're going to end up with a structure that looks triangular in a sense, that's referred to as a tree. We can do that with different kinds of problems, let's say. So in evaluate, and the problem that we did in the lab, you saw a problem like this. So what we did was we took one element, the big string that you see at the top, and then we divided that into two parts. So we branched off into two parts. And then one part, say, is the red side, 1 times 17, and the other side is 2 times 3 plus 4 times 9, which is the green part. And then each one of those is going to be branched off into two parts. And each one of those parts is going to be branched off into two parts until we get to the leaves. And once we get to the leaves, we can do some sort of operation, and then we can bubble back up. So that's the basic idea of any kind of tree. We can use trees in lots of different ways, but the main idea of what we're going to be using is nodes. So in this class, we're going to be using nodes for a tree, and we are going to have three main parts to our node. We're going to have a variable that refers to the left node, a variable that refers to the right node, just like we did with linked list when we refer to the previous node and the next node. And we're also going to have data, just like we did with the linked list. It's going to hold some value inside. We're going to start by building a tree that holds numbers. In this case, we have a sequence of numbers that's somewhat random, 6, 5, 7, 9, 4, 8, 2, 3, 1, in that order. And we're going to start with a node that holds the value 6. Our first node is just going to go at the top. If there are no other nodes, or if the root node is null, then we're just going to place this new node with the value 6 inside of it at the root spot. Now that we have a root spot, the next node that we have is going to have to decide which side of that root node it's going to be placed on. Is it going to go on the left side or the right side? So by convention, we do if the new node is less than the previous node, then we're going to put it on the left side. Let's look at the next node. In this case, it's a node that holds the value 7. If the node is on the right side, then it means that it is more than the root node. So we're going to compare it first to the root node and say 7 is greater than 6. So we're going to place it on the right reference of the root node, which is number 6. Next, we get the node 9. So what we're going to do is we're going to compare it to 6, and we're going to say, is it more or less than 6? In this case, it's more than 6. So we're going to go to the next node, and we're going to say, is it more or less than 7? In this case, it's more than 7, so we're going to place it on the right side of 7. Let's take number 4. This node holds the value 4. We're going to be comparing it to the root node first. Is it more or less than 6? It's less than 6, so it's going to go towards the left side. And then is it more or less than 5? It's less than 5, so it's going to go on the left side. Node with value 8, compare it to 6, go to the right. Compare it to 7, go to the right. Compare it to 9, go to the left. Node with the value 2, compare it to 6, it's less than. Compare it to 5, it's less than. Compare it to 4, it's less than. Place it on the left side. And we continue to do each one of these until we find a reference that is null, in which case we can insert ourselves. So in this case, 6 doesn't have a left reference that's null or a right reference that's null. So then we go towards 5. 3 is less than 5, and we would have to place it on the left side. And there is already a node there, so we're going to have to compare it to that node. Is it less than 4? It is less than 4. So we're going to have to compare it to the next node. And then is it more or less than 2? In this case, it's more than 2. Is there a node on the right side of 2? There is not a node on the right side of 2. Then we can just go ahead and place that there. And then the last one would be 1. We would just place 1 all the way down that branch. Now, let's look at different levels. So in this case, we're going to go over a few terms moving forward for different types of ways to describe a tree. At the top, we're going to find level 1. Then we're going to find level 2. For this spot, we're going to find level 3. We're going to look at level 4. And finally, we would have level 5. Now, there are ways to represent how far down we can find a leaf from a current node. So we have levels to represent like at what spot we're looking at. So if we're looking at a node with the value 8, we're looking at level 1, 2, 3, 4. So that's a way that we can describe it. We can also describe nodes by height. We can say this node, it has a height of 5. Now, why does it have a height of 5? Because we go towards the deepest leaf that we can find for that node, and we follow the path, and we count that there are 5 nodes from this node all the way down to the deepest leaf, including the node itself. If we look at another node, this node has a height of 3. So we look at the deepest node, and then we count up, and we count the node itself. If we look at this node has a height of 2, because there's only 1 under it. And finally, we can look at this node, and that node has a height of 1. Let's look at another term called subtree. Now, it is important to go over these terms because it's going to help us understand what we're talking about when we're doing our problem set. So there are different ways to program a tree, but you're going to need to understand all of these terms to be able to program a tree. What's a subtree? Well, a subtree is just a tree within a tree. So we've got a subtree here composed of 3 nodes. We've got a subtree here composed of 4 nodes. We've got a subtree there composed of 2 nodes. But we do not have a subtree here because they are not connected within the same path. You would have to skip over some to be able to get to the other side. So 2 and 4, you'd have to skip 5, 6, 7. You can't follow a linear path to get to it. So in this case, this set of nodes are not a subtree. Now, we could try and say build another tree, and I would advise you to uh, create this particular tree in this particular order and see what it looks like. Interestingly enough, what's going to happen to this tree is that it's not really going to look like a tree. So try it out, see what it looks like, and then you can always ask some questions about what this happens, but we are going to go over in future lessons on how to fix this phenomenon.